Good evening, class. Here's College Algebra practice test number 4, module 4, covering chapter 7 and 8. Chapter 7, systems of linear and nonlinear equations. Chapter 8, analytic geometry. And as always, a pledge: when you take the exam, you take the exam on your own. And I can't emphasize this enough. So we're going to start with the systems of linear and nonlinear equations. Systems of linear and nonlinear equations. If the system of linear equations results in two parallel lines, the system is inconsistent. What is an inconsistent system? The system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. They look like that. Here's the two. If you solve for y, you see they have equal slopes, different y-intercepts. If you solve it by, let's say, addition or substitution, you notice a contradiction such as 0 equals 7. Two numbers that are different indicates the system has no solution. The system is inconsistent. If the system of linear equations results in two intersecting lines, the system is consistent. So it's a consistent system with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. So, such as this x plus y equals 5, y equals 2x minus 4, completely different slopes. So as long as M1 is different than M2, you get two lines that are going to intersect. Point of intersection is the solution. And if the system of linear equations results in a single line, the system is dependent. So consistent system with dependent equations. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. So they are at top of each other in essence. So, for example, these two, they may look different, but if you solve for y, they become identical. M1 is equal to M2, B1 is equal to B2. And if you were solve it by any method, for example, addition or substitution, an identity such as 0 equals 0 indicates the system has an infinite number of solutions. The equations are dependent. So I can't emphasize this enough. I hope everybody's fine with that. We want to solve the systems here, starting with this. If we want to go with the addition method or substitution method, either one works. It's easy to see that as far as the addition method is concerned, you're going to find you're going to multiply this by some number such that the coefficient of x for the first one and the second one, those are opposites. For example, if we multiply this one by 5, it happens as far as the y is concerned the same. So let's multiply the top one by 5. Then this becomes negative 5x plus 10y minus 5. And as you can see, we can add them up in the following manner. This is called addition method. These two cancel each other, or they're also called elimination method. They cancel each other. So the left side has nothing, that means 0. But the right side becomes positive 1. This is clearly a false statement. Therefore, this is an inconsistent system. The solution to this system is an empty set. This is a notation for an empty set, or phi, a Greek letter representing an empty set. Solve this system. First, you decide if you want to go with the addition method. And by the way, to go with the substitution method, the coefficient of x should be either 1 or negative 1, otherwise it becomes more difficult. So we're going to go with the addition method. If you want to get rid of the x, you multiply this one by 5, this one by 2. If you want to get rid of the y, you multiply this one by 3, this one by 7. So let's do one of them. It doesn't matter which one. If I multiply the first one by 3, I get 6x minus 21y equals 9. Bear in mind, When you multiply both sides by the same number, you are not changing the nature of the equation. This one, the product of these two, negative 35x plus 21y equals 49. And now, if you add them up, these two cancel each other. They add up to negative 29x. They add up to 58. Divide both sides by negative 29, x becomes negative 2. Now use one of the equations. It doesn't matter the first one or the second one. For example, the first one, plug in negative 2. So we get minus 4 minus 7y is 3. Move this or add 4 to both sides. Divide by negative 7. And y becomes negative 1. And you write it as a pair. It's a good idea. Of course, however they ask you to do that. Notice we used equation 1. So you must check. How do you check? Use the equation that you haven't used to get the y. The second one we have not used. So minus 5 times x, which is negative 2, plus 3 times y, which is negative 1. And you're going to ask yourself, is this equal to 7? Well, this is 10 minus 3, and it's equal to 7. It checks. You have to check, and it literally takes a couple of seconds. All right, let's look at matrices. The method of matrices, the question is, what are matrices in the first place? They are defined as a rectangular array or table of numbers. Okay. A matrix with m rows and n columns has dimensions m by n. So take a look. We have 1, 2, 3, and we go this way. How many m rows? This way. Now column. First column, second, third, and it's n columns. As far as the rows, and we represent any of those entries, any of those elements as A, I, J. I, the first one refers to the row. The second one refers to the column. So, for example, this one, of course, both of them are 1. Both of them are 2. If you look at this one, A13, that means row number 1, column number 3. 1, 2, 3. If you look at this one, row number 3, column number 2. Row 1, row 2, row 3, column 1, column 2. So that's how you read them. And it's A, I, J, and that gives you the precise location. A square matrix has the same number of rows and columns. The dimension is n by n. So if the number of rows and columns are identical, we call them a square matrix. And normally we say n by n instead of n by n, but it doesn't matter. We can add matrices with same dimensions only. So if you want to add two matrices, they must have identical dimensions. Clearly, this is 2 by 2, this is 2 by 2. And how do you add them? Okay, you add A11 to B11 if it's called B11, the other one. Okay, so you add the same position in the following manner. So you add 5 and negative 4. So A11 and B11, they add up to 1, and that's, let's say, C11, the first entry. You add negative 6 to 6, the result in 0. You add 8 and 8, same location, you get 16. You add 9 and -3, same location, you get 6. So take a look. 5 and -4, 1. -6 and 6, 0. 8 and 8, 16. 9 and -3, 6. That's how you add it. It's very simple. And if they have different dimensions, you can't add. That's as far as addition. Identical dimensions, identical location can be added. Product is a different story. The product of AB of an M by N matrix A and an N by K matrix B is an M by K result. In other words, the number of rows comes from the first one, the number of columns comes from the last one, and the number of columns for the first one must be the same as the number of rows for the second one. Otherwise, you can't. So if you're multiplying, the first thing I suggest you do, just look at the size, the dimensions. So this one, 1 and 2 rows, 1, 2, 3 columns. So this is 2 by 3. This one, 1, 2, 3 rows, 1, 2 columns. And because these two numbers are identical, everybody, the number of columns for the first, the number of rows for the second, they are identical, we can multiply. Then the result, the number of rows comes from here, the number of columns comes from here. So the first thing you do, you make sure this thing is correct and you take it from there. Now, how do we multiply? First, let me erase my word. We are multiplying this row by this column. And that would be our first entry. So -3 times -6 plus 4 times 2 plus 2 times 3. This is 18, 8, 6. They add up to 32. And that would be your first entry. Then you multiply, let me again erase my word. Then you multiply same row by the second column. So what do you get here? You get -3 times 4 this time. So look at this one. So you change this one to 4. 4 times, instead of 2, now you're going to multiply by 3, the second one. 2 times -2. Add them up. This is -12 plus 12 minus 4. So negative. Now we are done with the first row. We go with the second row and we multiply this one by the first column again. So erase my word. So we're going to multiply these two. Okay, this one by this one. 5 times -6 plus 0 times 2 plus 4 times 3. This is -30. This is nothing, 0. This is 12. -30, positive 12. You get -18 here. So minus, let me just write that. It goes in here. And finally, you're going to multiply these two. So let me write it here. Maybe underneath that. Doesn't matter. 5 times 4 plus 0 times 3 plus 4 times -2. 20 plus 0 minus 8 equals 12. So we get negative 18 here, 12 there, and I'm going to erase my work. So here's the synopsis of what we do. So this row times this column gives you this one, times the second column gives you this one. The second row times this column gives you the first entry of the second row, times the second one, the second entry. And you're done. That's how you do the multiplication. So the multiplication gets a little bit involved, okay, everybody? So, matrix method to solve systems of linear equations, REF, row echelon form method. Apply row transformation to get ones along the diagonal, a leading coefficient. So, in other words, we'll see what they are. Whatever we do to an equation, you can do row transformation, because remember, for an equation, for example, you can multiply both sides by the same thing. So we are talking about the very first entry. Okay, so row echelon form, apply row transformation to get ones along the diagonal. So this becomes 1. You make this one 1. You make this one. You get all of them. You make them 1. And then add 0. So ones along the diagonal called a leading coefficient. A leading coefficient is 1. And zeros below the augmented matrix. So if this is 1, you make everything 0 underneath. This is 1 underneath 0. This is 1 underneath 0. This is called row echelon form. At above that, it doesn't matter. RREF makes the top 0 as well. Reduced row echelon form method. Apply row transformation to get ones along the diagonal and zeros both below and above the augmented matrix. Every leading 1 is to the right of the 1 above it, and any non-zero rows are always above rows with all zeros. So that's the idea, everybody. Let's make some sense out of this by looking at a very simple example which means something that we've already done. We already solved this, but I want to go with the method of matrix. And the very first thing we want to do, we want to come up with the augmented matrix. So the question is, what is the augmented matrix? Well, you just write the coefficients. So instead of x, you would put here -1. Instead of y, you put 2. On the right side, you put -1, 5, -1, 6. So take a look. Or if you want to go column-wise, -1, 5, 2, -10, -1, 6. And normally with the line segment or dashed line segment, you separate them. This is important to understand that the first one is called the coefficient matrix, as far as the terminology. This last column is the constant that represents the constant, okay? Each column on the left represents a different variable. This represents the x. This represents the y. What about this line segment? Represents the equal sign. So my point being, I hope you see, if you are given a system, you can clearly and easily come up with the augmented matrix. If the augmented matrix is given, you can go back to the system. By the way, the system normally x, y, z, and so forth. If it gets really involved, they say x of 1, x of 2, x of 3, x of 4, if you have so many variables. So a quick recap. First, you want to come up with the augmented matrix. That means just write the coefficient of x in the first column, the coefficient of y in the second column, and the constant in the last column. And this, in essence, represents the equal sign. Now, remember, for the row echelon form, we need to make the first entry. So first decide what is it that you need to make this 1. How do you make this 1? Remember, row transformation is the same as working on equations. I can multiply this entire row by -1, and this becomes positive. And why is it okay? Look at this equation. I can multiply it by any number I want, as long as it's not 0, okay? So we're going to write negative R1 goes into R1. That means multiply this by -1. Don't change the bottom. This becomes 1, this becomes -2, this becomes +1. That's the meaning of it. And you have to work on it in this format. So number 1, you make this one. The second one, and you go down, meaning underneath that, doesn't matter you have 1 or you have 10 rows, each one must go to 0. So you want to change the 5 to 0. So obviously you can't multiply by 0. That is not doable. So what do? You do row transformation. So you can use other rows if you want. For example, if I multiply the first row by 5 and subtract it from the second row, I get 0. So I'm going to say -5 R1 plus R2 goes to R2, or you can write it. Sometimes they write it in this fashion, row 2 -5 row 1. R stands for the row, whatever is easier. So what it means is that you're combining the first and the second equation in some manner, okay? More specifically, you're multiplying the first equation by 5 and you're adding it to the second one. That's the idea if you were not to change that. This one we had to change it. So we are going to repeat the first row. We're not going to touch it. And we're going to multiply this one by 5 and subtract it from this. 5 times 1 subtracted from 5 is 0. 5 times -2 is -10. Subtracted from -10, you get 0. 5 times 1, 5. Subtracted from 6, you get 1. I hope everybody can see that. Now, in a row transformation, if a row is all zeros except the last one, that means it's an inconsistent system. So the corresponding equation for the last row, 0 equals 1. Let me, in fact, write it so you see what this corresponding means. If you look at this one, this means 1 times x, and I'm going to put 1 for emphasis, -2 times y equals 1. This one means 0 times x plus 0 times y equals 1, and that's what they're referring to. And this is a false statement. Okay, so the corresponding equation for the last row, 0 equals 1, is a false statement. A row of all zeros except the last entry. Everything is 0 except the last entry. Therefore, the system is inconsistent, and the solution to the system is an empty set, which we show it with a couple of braces or a phi, a Greek letter. So I hope everybody is okay with that. Okay, now I'm going to show you how to use a graphing calculator for this. If it gets involved, you should know that. So first, let me erase my work. How to enter matrix editor. Number 1, matrix editor found by pressing second and x to the power of -1. Use the arrow key to the right to edit the dimension you want. Put all the entries using the arrow key, press enter. So you go, for example, with the TI calculator, okay? Matrix editor found by pressing second x to the power of -1, and then you do REF. So take a look at what I'm saying is that. So matrix A, I'm looking at this one. It has a name, A, B, C, so forth. It's a 2 by 3. I hope you see that 1 and 2 rows, 1, 2, and 3 columns. And you put it in here. So -1, 5, 2, -10, -1, 6. And then you do REF. If you do row echelon form, it gives you 0, 0, 1. Now, one thing which is very important, you may not get exactly this one because the row transformation done here, it may have a different order. However, the fact that the bottom is 0, 0, 1 indicates the same answer, and I can't emphasize this enough, everybody. We want to solve this system, and you should remember that we've already done that. So let's go over that. First, we want to come up with the augmented matrix. and augmented matrix, that means just write the numbers 2 minus 7, 3 minus 5, 3, 7. And it may be easier to go column-wise. 2 and negative 5, that's the x column. Minus 5 and 3 is the y column. 3 and 7 is the constant. And this line segment, it means an equal sign, right? All right. So first thing first, we want to make this number into 1. So, and you can do row transformations. You can do fraction. If I multiply by 1/2, that's really the easiest and fastest. The problem is it creates fractions. And when you want to add things up with fractions, it's more complicated, but it is absolutely your choice. So one easy way is that if we multiply this one by 3 and then add this one, 3 times 2, 6 minus 5 becomes 1. So we're going to write 3 times R1 plus R2 goes to the new R1. So again, 3 times this, 6 minus 5, the first entry is 1. And by the way, the second row remains unchanged, minus 5, 3, 7. So in essence, you can rewrite this. But what happens up here, it's going to change. So we said 3 times R1 plus R2. So if we're going to multiply now the negative 7 by 3, we get negative 21. Negative 21 add R2, and now this changes to negative 18. Now we are going to multiply this one by 3, we get 9, and 7 is 16. One more time. The second row, keep it. Then first row, how do we get that? Multiply the first row by 3 and add it to the second. That's what we do. Okay. Now, the next step is to make this one 0. So let me first write the first row unchanged. Then I'm going to write, okay, I need a 0 here. So how do I get that? Okay. So to get 0 here, I can multiply this one by 5 and add it to this one. I'm going to write 5 R1 plus R2. So 5 times 1 and negative 5 gives me 0. So the first entry below the 1 must be 0. We just got it. How do we get this one? 5 times negative 18 is negative 90 plus 3 is minus 87. 5 times 16, okay, minus 7, it's 87 also. This is negative, this is positive. So this 0 was the key. All right. Finally, we want this one to go to 1. So all you have to do, divide everything by 87, more specifically by negative 187. So negative 1 over 87, R2 goes to R2. By the way, your transformation should be such that the one that you worked so hard to get doesn't change. So this 0 shouldn't change, okay? And if I multiply this row by any number, it doesn't matter, the 0 remains. But now this one divided by minus 87 is 1. This one becomes negative. And now obviously, to make sure we understand what happens, we're going to write the corresponding system, although you don't have to. This means 1x minus 18y equals 16. This means 0x plus 1y equals negative 1. And basically, this means y equals negative 1. And I hope you remember that we had gotten. And then you can put it in here. This is called back substitution, and find the x to be negative 2. If we want to go with the matrices, we're going to put this in a calculator. And again, the size must be 2 by 3. 2 minus 7, 3, minus 5, 3, 7. And we're going to do, if we do REF, again, notice this is different than what we have here, but the second row is identical. Okay, so they did the fractions. So we have one of the solutions. However, if we do RREF, then this is the answer. And that's what we had got before. Very straightforward, everybody. Okay, so I want to make sure that you're comfortable with the concept of a matrix. So let me quickly show you in case, again, it gets involved, you can use calculators. Okay. So we're going to press second and X inverse. That gives us a calculator. That gives us the access to different matrices. For example, A, B, C, D. I hope you see that. Okay. Math will give us access to REF and so on. So let's go back to the names and the A, second. Okay. Let's choose this one. Okay, I want to edit that. Okay, so we want it to be 2 by 3. That's the first thing I want to make sure you understand. So we use the dimensions and we're going to input 2 here. Minus 7 here. What happened? Not coming up. So that's fine. That's fine. We have 2. Enter. Minus 7. Enter. Positive 3. Enter. Minus 5. Enter. Positive 3. Enter. 7. Enter. So we entered the matrix, the 2 by 3, the augmented matrix. And now we are going to go to math, bring it down. REF. Okay. So second X, we are going to go to math. Okay, why is this acting up? Let's do go to math and bring it down to REF. Okay, REF. No, no, clear. Second, X. Bring it down to REF. REF, Roy echelon form of matrix A and enter. And this is what the calculator gave us. And again, you can do REF. Let's go to the matrices again. Math. Let's go down to R. The next one is REF. And now second. Okay, A matrix. Take a look. It gives us the answer. So I hope everybody can see how it's done. I took some time to show you how this thing works, although I had put it down for you. So, and now we are ready to actually move on. So let's do so. All right. Cramer's rule. Use Cramer's rule to solve the system. So we already have looked at various methodologies. I want to discuss this method as well, everybody. So first, how do we get to Cramer's rule? By determinant. So what is the determinant? The determinant of a 2 by 2 matrix, A, B, C, D, is their cross product, okay? AD minus BC. That's by definition, everybody. Cramer's rule for two equations containing two variables. If we have AX plus BY equals SCX plus DY equals T, what do we do? First, the coefficient matrix is A, C, B, D. If you write that, you can calculate that determinant. We call it D and we put it at the bottom. The top is that, so in this case, in other words, if you look at this one, this will be what we are going to call it D. If we want to get to X in the numerator, we replace the X column with the constant column ST. For the Y, we replace the second column, the Y column, with ST. So this is the equation, everybody. X, look at the denominator. The denominator is the determinant of the coefficient matrix in both cases. And we call it simply D. Replacing the first column, okay, by the constant ST, that gives us what we call D sub X, the determinant for X, and the ratio is the answer. If you change the second column, we call it D sub O. Okay, so couple of things. D, which is the determinant of the coefficient matrix AD minus B, can't be 0. Note, because the denominator. We replace the first column of D by the solution matrix D sub X, and we replace the second column of D by the solution matrix for D sub Y. So I hope everybody is following that. So that's something we want to be careful of. If D is 0, that means the denominator is 0. And at least one of the determinants, D sub X or D sub Y or D sub Z, I say D sub Z because there may be a 3 by 3, okay, is different from 0, then the system is inconsistent and the solution set is an empty set. In other words, we don't have a solution. So if the bottom is 0 and the top, one of them is non-zero, there is no solution. That's what we are saying. If D is 0 and all of the determinants D sub X, D sub Y, and if you have a 3 by 3 D sub C are equal to 0, then the system is consistent and dependent so that there are infinitely many solutions. That's how you come up with the answer. Now, to do this, first, we are going to write the determinant for the coefficient matrix. Remember, the coefficient matrix is this 2 minus 5, 7 plus 3. If you go column wise, it might be easier. The column of X, 2 and minus 7, the column of Y, minus 7 and 3. And according to this determinant thing, you have to multiply these two, you have to multiply these two. So 2 times 3 minus negative 5 times negative 7. So this is positive 6. This is minus 35. And you get negative 29. Now, for D sub X, the first column, everybody, goes away and it becomes the constant or the solution. So replace this with 3 and 7. And now cross product. 3 times 3 minus 7 times 7. 9 plus 49 is 58. Now, we want D sub Y. Go back to this. Keep the first column. Change this one to 3, 7. So the second column will change to 3, 7 now. And you do the cross product. 2 times 7 minus 3 times negative 5. So you have 14, you have plus 15, you get 29. So X is D sub X over D, Y is D sub Y over D. So X is D sub X 58 divided by negative 29, and Y is D sub Y 29 divided by negative 29. When you divide these two, you get negative 2. When you divide these two, you get negative 1. So D sub X 58 divided by D negative 29, you get negative 2. That's for X. For Y, D sub Y, which is 29, divided by D, which is negative 29, we get negative 1, and we get the same answer as expected. So this is a different method known as Cramer's rule, everybody. Now, of course, this becomes much more interesting and complicated if we add to the number of columns and rows, okay? For example, a 3 by 3. So how do we find, so it's a 2 by 2. How do we find the determinant, for example, for a 3 by 3? Let's quickly go over that. So we want to evaluate the determinant here. The methodology is that first you decide to expand it with respect to one of the rows or columns. Now, of course, I'm going to go with the first row just because I want you to see how it's done. But a wise idea would be to go with the row or column that has the most number of zeros, because that has an effect and it makes a difference and it becomes much faster. So how do we do this in general? Okay. So if you are expanding it with respect to the first column, okay, then you're going to multiply A sub 1, 1, and you're going to cross this one also times, just for this, the very first entry, and this is the, so you cross this out and you look at the matrices for that. That's a 2 by 2, you can handle it. After that, this is the row that you're expanding, remember that. The second one, you cross this one out, and you get A1 2 times whatever is left, but has a negative sign. And finally, and you're expanding with respect to, you drop this and you calculate the determinant for this one plus this times those. So this is the idea, and I'm going to quickly go over that one more time. So this, you are expanding it with respect to the first row. So A1, 1. So you cross this row and you cross this column, A11 times whatever is left. This one takes a negative sign. They alternate positive, negative, positive, and there's another methodology of finding it. I'll show you in a moment. And then if you cross this one out, you have A21, A23, and so forth. So this is how you find the determinant, okay? Now, as far as the terminology is concerned, the 2 by 2 determinants, this one, and this one, are called minors of a 3 by 3 determinant, okay? For example, this one, look at this one, we call it M11. Cofactors. The cofactor of a matrix is obtained from the minor of the matrix, and it's equal to the product of -1 to the power of I plus j and the minor of the matrix. Now, in other words, including the sign. How do you include the sign? Again, you can alternate, as I said, positive, negative, positive, or -1 to the power of I plus j. Take a look, everybody. This one, I is 1, j is 1. So -1 to the power of 1 plus 1 is -1 squared, is +1. That's why this takes a plus sign. But if you go with this one, for example, A12, right? So -1 to the power of I plus j, 1 plus 2 is -1 cubed, and it's equal to -1. And that's why you get this negative signs. That's why you can calculate it, or you say they alternate. It's your choice, everybody. Okay. Very straightforward. But in any event, let me erase my work. Again, we're going to go with the first row, everybody. But like I said, a wise idea is not to go with the first row, go with the second row or second column because it has a 0. But in any event, how does this work? So let's start with this. So if we want to go with the first row, we expand it with respect to the first row. Then we have 5, and we cross this out, and whatever is left. Let me actually cross it out so you can see. So you see, this is the matrix. Okay. Now, as I said, you can see that it alternates, so you can put a negative sign. And the second one, you're going to cross this out, you're going to cross this out. So this number, so you're going to put minus, and then this number, -8, times this 3, 4, -5, 1 determinant. Finally, if you want to go with the alternate, positive, negative, this is positive. So +6, I'm going to erase. So cross this out, cross this out. So +6 times this determinant. So this is the way you calculate it. Class, of course, there's sort of an easier way I'll show you. So now it's a 2 by 2, it's a cross product. It's very simple, okay? So you multiply this, so 5 times. You multiply these two, 0 times 1 minus, okay? You multiply these two, okay? Minus 8. This one is obviously -1, and keep it or change it to plus. This is 3 times 1, 3, minus -5 times 4, -20. This one, 6 remains. 3 times -2, -6, and the product of these two, 0. So you write it in this fashion. Now, this is +8, so 5 times 8. This is -8, 3 minus -20, that means 23, 6 times -6, and you add them up. 40 and 184 and -36 becomes 188. Now, when you do it by hand, as long as you can do one by hand, the assumption is you can do more by hand, okay? You should be able to do it. But when it gets complicated, you can always use a calculator. Now, I'm going to show you a second method, how to do this by hand, a different method also that's interesting, okay? So a second method is this. you write two matrices next to each other. So you're going to repeat that next to it. And then you go this route, add them up, the determinant, you multiply those, and then you multiply those. The blue ones, you add them up. The red ones, you add them up, and you subtract the sum of red from the sum of the blue. Or you can see positive for the blue, negative for the red. So if I want to do the same thing for this one, I'm going to write exactly the same thing here. You have two of them, okay, class? And I start with the very first one, and I go down with an arrow this way, and this way, and this way. Okay, that means 5 times 0 times 1 plus negative 8 times 4 times negative 5 plus 6 times 3 times negative 2. That's the blue one. Now, I go from here up diagonally. I multiply them, I add them up, and I subtract from this. So minus brackets, 5 and 4 and negative 2 multiply, plus minus 8, 3 and 1 multiply, plus 6 times 0 times negative 5. So one more time. Look at the blue one, multiply them and add them up. Look at the red one, multiply them and add them up. Red one's the sum minus the blue one is your answer. Okay, so this is 124 minus 64. You get the same answer. This 188. This is a lot faster, everybody. And again, as I mentioned, it is easier to expand across any row with most number of zeros. Again, I highly recommend you try this. Expand it with respect to this row or this column. And please understand, when you go with this row, the first entry starts with negative, because this one is second column, a second row, first column. Okay, negative 1 to the power of I plus j. Be careful with that. Okay, and so you can also use, you know, a calculator. So matrix B is 3 by 3, and you put it in. And all you have to do, determinant of B, and it's 188. In a split second, you have the answer. All right, let's solve this system. And we're going to solve it by different methods for practice. First and foremost, in order to make it easier, let's call this equation 1, equation 2, equation 3. So we know what we are dealing with. Now, if you want to do this by hand, the idea is that it's a 3 by 3. You want to bring it to 2 by 2 and then 1. That's, in other words, the number of equations you want to bring them down. So first you decide what variable to eliminate, and normally the one that is the easiest one. So in this case, if we add equation 1 and equation 3, okay, and equation 2, my apologies, we notice these two. Let me just put them together so you can see them. These two, if we put them together, if we add these two cancel each other. We get 5x plus 3z, and these two add up to positive. So again, the reason I chose that, this is the least number of steps. Ultimately, that's the goal. You don't want to go with too many steps. Now, equations 1 and 2 were used, and equation 3 is the only one that has not been used yet. So you must use equation 3, and doesn't matter which one, equation 1 or 2. So let me erase my work. So this we must use. This we must use because we haven't used. So we decide which one is easier to use it with. But what variable you get rid of the same variable? Over here, y is missing. So we have to get rid of the same variable y. Okay. So because you want to get rid of the y here, if you multiply this one by 3, this one by 4, it does the job. So this one becomes 9x minus 12y plus 6z equals negative 45. This one we multiply by 4, 8x plus 12y plus 20z equals 80. And so when you add them up, these two cancel each other. 17x, 26z, 35. And we call this equation number 5, and we put it next to equation number 4, and notice what we have now. We had a system of 3 by 3, now it's a 2 by 2. We had 3 variables here, now we have 2 variables here. Now you get rid of one of the variables, and it doesn't matter. If you want to get rid of the x, you want to multiply this one by 17, this one by 5, one of them negative, class, okay? If you want to get rid of the z, this one by 26, this one by 3, one of them negative. So let's multiply this one by 17, this one by negative 5. So 17 will give us 85x plus 51z equals 17. Minus 5 gives us minus 85x minus 130z minus equals minus 175. And when you add them up, these two cancel each other. We get negative 79z equals negative 158. Division by negative 79 gives us the answer for C. And now we have to get the other ones, and we're going to go to one of these two, not the original ones, because we can't. We put this into one of them, and we find the other variable. In this case, if we put it in equation 4, we can find x. So 5 times x, 3 times 2 equals 1. It becomes 6. Move it to the other side. Minus 6 becomes negative 5. Divide by 5. And x becomes negative 1. Now you go to one of the original equations now. You can go to any of them. Let's say the first one, 3x minus 4y plus 2z equals negative 15. So we get 3 times x, which we know is negative 1, minus 4y plus 2 times z, which we know it to be 2. Is to add up to 1, go to the other side, negative 1 become negative 16 divided by negative 4. Y is 4, and we write the answers, negative 1 for x, 4 for y, 2 for z. Please understand, we used equation 1 to get to this. You must check it with both equations 2 as well as equation 3, and it takes a split second. It doesn't take long. That's okay. For example, 2 times negative 1 is minus 2, 4 times 4 is 16, 1 times 2 is 2, they become 16. You can easily see that. All right, so we're done with that. What I want to do is I want to work on this using the augmented matrix. And it might be easier to write the x column 3, 2, 2, the y column negative 4, 4, 3, the z column 2, 1, 5, and the constant or the solution minus 15, 16, 20. So it might be easier to go column wise. We put that into a calculator. So it's a 3 by 4. We see the first column, the second, the third. There's not enough room to see the second. So I show you the last column, and I'll show you the last column. And so what happens next? We are to do REF and I'm going to do REF to show you the answer. So when you do that, then you, okay, and this is the last two. So we have the first two columns, the second two, and we end up with that. Now, what does that mean? This means Z is 2. This means 1y minus 1 over 20 z is 39 over 10. This means 1x or simply x minus 4/3 y plus 2/3 equals -5. By the way, I've changed it to a fraction. See, answer, I changed it to fraction purpose. Or instead of REF, let's do RREF. This is row echelon form. Now reduced row echelon form. And now the last column is exactly what we had there. If you go with RREF, you actually get to the answer. So I showed you by hand, step by step, and I showed you with the calculator. As long as you understand how it works, when it gets complicated, you can always use a calculator. We want to solve this system. If you want to do it by hand, we notice that if we okay, so we have this one, x plus y plus z is 14, 2y plus 3z is minus 14, and this minus 16, y plus 24 z is negative 112, and these two have y and z only. Let's combine these two and get rid of one of the variables. For example, let's multiply this one by 8. When we do so, we get, this is negative, we get positive 16y plus 24z minus 112, and if we add them up, the left side is 0, but the right side is something else, negative 224. Anything else, this is a false statement. And that means there is no solution. The system is an empty set with no solutions. Now, if we use a so this was done by hand. If you use a calculator, we put the augmented matrix. Let's go with that and put it into a calculator. X class. Take a look at X. We have 1, and we don't have X here. 1, 0, 0. The Y, 1, 2, negative 16. The Z, 1, 3, negative 24. And the constant or the solution, 14, negative 14, negative 112. So I want to make sure everybody understands the first column. The first one has X, 1X, and the second and the third equations, they do not have any. So we do REF or RREF. In both cases, notice the last row. One of the rows, it doesn't have to be even the last row. They're all zeros, except the last entry. So I hope you remember. The corresponding equation for the last row is 0 equals 1, because this is 0z. Is a false statement. A row, I'm reminding you, a row of all zeros except the last entry. Therefore, the system is inconsistent, and the solution to the system is an empty set. So there is no solutions. That's really the bottom line, everybody. We want to solve this system and see 3x minus x. Let's multiply this one by 3. This is minus 3x, minus 9y, minus 6. And if we add them up, these two cancel out, these two cancel out, these two cancel out. 0 equals 0, which is a true statement. And as you recall, it becomes a dependent system with infinitely many solutions. And the way we write it, normally we write x and we solve for y in one of them. Okay, so over here, if you want to solve for y, let me just show you. When we say dependent, that means they have They are the same equation in essence. Both of them are identical. So x and here's the y. And how did they get that? Minus x minus 3y equals negative 2 minus 3y equals x minus 2 divide by negative 3. And that's what you get, okay? So, because when you have a dependent system, you keep one of the variables and the other variables, maybe more than two variables, you represent them as a function of the first one, or the second one, or the third one, but it's better to stick with the first one and then everything is a function of that. If we were to go with a technology, again, first and foremost, look at the first column, negative 1 and 3, the second column, negative 3 and 9, and the last one, negative 2, 6. And we are going to do REF or RREF, makes no difference. When we do that, we end up with a dependent. One other thing I want you to notice, I hope you notice that this is a multiple of this. Now, it doesn't matter that it's negative 3 times. If you multiply this one by negative 3, you get this one. So right away, it tells you these two are in essence identical and the two equations are dependent. If you do REF, the last row is all zeros. Again, one easy way. One row is a multiple of the other one. Therefore, the corresponding equation for the last row, 0 equals 0, is a true statement. A row of all zeros. Therefore, the system is dependent with infinitely many solutions. So when one row is all zeros, they are dependent with infinitely many solutions.